what does it mean for something to dilate or a dilation? Yeah.
All the angles are preserved, but
You're going too deep. I agree with you, but you're going really deep. Let's not go quite as deep first. What's it mean when something dilates, or when there is a dilation? Smaller or bigger, right, Stradler?
yeah, I was just gonna say like it scales up and down.
Yeah. Where do we see dilation all the time?
In your eyes.
Calvin?
In our eyes.
In your eyes. Why do your eyes dilate? What's actually the point of dilation? Megan? Scarlett?
Isn't it to get more or less light if you're
Yeah, more or less.
in a dark room, they'll get bigger. If you're in a light room, they'll get bigger.
Yeah, so they get bigger or smaller depending on how much light your eyes want to bring into process. So that's why when like your eyes hurt, it's because they're actually dilating really fast. So the quicker they have to change size, you're like, vampire. So, dilation, change of size, or really how far away we are from something, because it deals with depth. So, one way that you can think of dilation is, and this is really weird and you kind of have to let your eyes play a trick on you. If you think of like infinitely many triangles heading in towards the origin, and infinitely many triangles heading out of the origin, and kind of make that have depth where the green one's closer to you than the purple one, it can kind of help you understand why we normally dilate from the origin. Because if we draw lines from the origin through C and through C prime, that line could continue forever, and any point that we place on that line could be a dilation point, which would connect with my other three lines to make that dilation of the shape, or a scale factor of the shape. So we have our center of dilation, we call C here. C is our center of dilation that then lets me dilate however far out I want, as long as I'm able to then determine a scale factor, and my scale factor is the size of this compared to the size of that, set in a ratio and simplified. So let me check that I got all this. Dilation transformation with following properties. Yep. So, finding the scale factor here. Now I will tell you, lots and lots of people like to make mistakes here. What is our scale factor in this triangle? Ooh, now that I said lots of people like to make mistakes, now we seem nervous. Caleb?
Would it be B?
A reduction of 1 to 3.
Wait, B? Wait. B is enlarged. Wait, question. I'm confused on which one we're looking at.
So, problem
I'm
1.
referring to like which triangle we're referring to.
Ah, so XTR
XTR.
goes to X prime, T prime, R prime via a dilation with scale factor N from point X.
Alright, so I would say B.
You would say B. Oh, sorry, I think I looked there again. B enlargement N of 3. How'd you get 3?
Well, because it says 4, right? So it has X prime and also X. The T is 4. From T to T prime is 8, which means that entire thing is 12.
Ah, we have to look at the entire thing. Now, you guys are a pretty bright group of kids, but when you see the 8 and the 4, a lot of people quickly try to say, oh, it's doubled. Be careful, because the 8 is a segment of that edge. You got to look at the entire edge together. So, based on the order that it tells me, we know it's an enlargement as opposed to a reduction, because we're getting bigger. So be careful. Your scale factor has to state be higher than 1 if it's an enlargement, or less than 1 if it's a reduction. And I have the work showing out there. I know that one's kind of obvious, but I like to give you guys structure so you can refer back to it while you're doing your homework. So, find your dilation factor here to dilate JKLM to J prime, K prime, L prime, M prime. So we don't have any horizontal distances. Easiest thing to do is a straight countable distance. So what's the easiest way to approach this problem? Who can help me here? I'll go to Caleb again if nobody else. Okay, Carmen. I don't really care about the slope because, I mean, we could look at the slope and find out that we do have parallel slopes. I think what you might have been thinking was distance formula because we have diagonal lines.
Yeah.
But that's still pretty difficult, and I don't wanna, right? Like, that's tough. What's the easiest way to solve this problem? So we could apply our distance formula. That would work, but it'd be a lot of work. Ooh, Lydia? Or Lynn? Wow, I haven't done that at all this year. We do have a straight line here and here, so we can compare KL to K prime L prime and find our dilation factors that way. KL has a length of 4, whereas the prime length is 2, and this gives me a scale factor of 2. So we see that this is an enlargement.
No, it's a reduction.
Haha, my bad. So, all of this needs to be flipped the other way around. That's just a totally my fault one. So, take your prime points on top of your original 2 to 4, scale factor of 1/2. It's a reduction, which that was not on purpose, but that's how easy it is to get your stuff switched around. Enlargement versus reduction. That was just an honest, genuine mistake.
I figured it out by taking just one of the lines inside.
What do you mean one of the lines
Like,
inside?
I went from M to the other side. The side
So you took like the
behind
width of the shape?
Yeah.
So you kind of did like an altitude. Because remember geometry we can change. So you essentially kind of did an altitude. That's fine. That works too because I mean that's like breaking it up into triangles essentially. You were looking at similar triangles. So what you're really meaning is we could apply that if we don't have any straight lines, just make some straight lines. So if you missed what Calvin said, if we didn't have KL as a vertical, let's say all of these lines were diagonal, Calvin's saying he took an altitude essentially, so that has a distance of 4, and compared it to the other altitude. So you'd have to still be from the same point to the same point, but essentially then you're breaking it up into like a triangle, but that works as well. Brian? Yes. So if you ever need it,
Can you have it, Brian?
you said sharpener, right? So, what are the coordinates of this? Now, what is that telling me to do? We have this notation here. How would we read that? Caleb?
I think it's telling you to dilate the vertices of triangle PZG.
Yeah.
2.
So we would read this dilation by a factor of 2 to triangle PZG. So remember, the image is after we do whatever we do. So we have to dilate by 2. Yeah, question?
When you say dilate by a factor of 2, do you mean multiply it or actually yeah.
So dilations can only work through multiplication.
Okay.
So you're either multiplying by an integer or a fraction. So if it's bigger than 1, it's an enlargement. Less than 1, it's a reduction.
Wouldn't you have to know the center of dilation?
Yeah, that's exactly what I was getting. If you're not told where the center of dilation is, it's assumed to be the origin. Because we almost always dilate from the origin. It's rare that we dilate from anywhere other than the origin. So if we knew our points to begin with, and we do this tomorrow, in the video that I made, I talk about you don't have to put the shape on a graph. You don't have to actually draw it. You can just do all the math and reason through it. So if I knew the coordinate locations, which I could write these down, all I would have to do is multiply them each by 2, and I wouldn't actually have to draw it. Or if you want to draw it and not think about the math, whatever you do to get from the origin to that point, just do that again, or essentially double the movement. So if I went 2 and then 1, I can go another 2 and then another 1. That doubles my movement. and P prime is now here. Z went up 1 over 2, so instead I'll go up 2 over 4. And G only goes down 2, so now it'll go down 4. And G prime will go up there. My new shape will be right here. Now, why is one side on top of the other side? Don't most dilations then end up not sharing any features?
Because that side intersects the center of dilation.
It is on my dilation point. Anything on your dilation point can't go anywhere. So do not let that strike you as odd. That is perfectly fine that we are on top of it. Any questions? I could have probably done this lesson and the next lesson combined, but it's fine. We're moving a little bit slower. So now we have dilation by a factor of 1/2. So with this one, I'd advise you not to draw it. Let's just write them out. So I want you first to notate P, Z, G where they are right now. This is what we do tomorrow. So P is at a +2, -1. Z is at -2, +1. And G is just 2 down on the y-axis. After we dilate, we get P prime, Z prime, and G prime. Where are these going to end up? Dilation factor of 1/2. Strabo?
I said that P was going to end at 1, comma, -0.5. And Z was -1.5.
-1 and then point.
Yeah. And then G was 0, -0.5.
Boom. Any questions? So we have a magnifying glass that is magnifying at 7 times. So the scale factor of the enlargement is going to be 7, and we look at this apple seed under the magnifying glass, and in the image that we see, it is 1.75 inches. Since we know that was 7 times multiplied by the original, and this is what scientists do to try to figure out the like size of cells, like certain cancer cells and different things when they're trying to figure out, what's our course of action. You gotta figure out how big is that. So if I know that I'm using a microscope that's magnifying by 1,000 times, then I can use the measurement that I can get on that screen. If you've never seen how microscopes work now, they're pretty much often connected to a computer. So you're not actually looking through the scope, you're looking at a screen that is looking through the scope. So you can then use that math to work backwards. So if we use this math to work backwards, we can see the actual length of that seed would be 1/4 of an inch. So likewise, we can take that and use it on this. Height of a documentary computer screen is 20.4 centimeters, and when I change the zoom from 100% to 25%, the new image is the dilation of the previous image with a scale factor of 0.25. So what would be the height of the new image? So our new will be 1/4 of the original. What would it be? Oh, this is head math. What? 5.1, right?
5.1. Stop hitting me, bro.
Yeah, that's really, I should have combined today and tomorrow's lesson. And then, so,
We need this time, I think.
do we have any other questions from anything from chapter 6? Anything. Like any homework issues, yeah. Is it homework or notes or what? Homework. I'll pull it up. So I'm going to pass out today's homework. You can work on that, or I'll take any questions from the rest of chapter 6. We're taking your Mastery Friday for this chapter. So,
Oh my lord.
so it's Monday. It's Monday though. So that's a lot of time.
Not really.
What are we taking? Today's the most Monday.
Yeah, the 7th graders could not deal with lunch today.
Hudson.
Like we had so many spills, just one after the other.
Just a Monday.
Okay.
Isn't hamburger next week?
I believe, yeah.
Oh
And then
my
I won't
God.
have you guys. I don't get to
It's
see
kind of like my brother.
Sorry, somebody had a question over here. Somebody was asking.
I was asking if you say that.
Oh crap, it's still filming.
Yeah, maybe she did. I forget.
think you
I don't
should
remember
make
where
your
they're
wife
from,
proud.
which makes me think I didn't buy them.
I feel like I ask you questions about your wife. When
Emma, when are we together?
So, 4. Wait, is it G or K?
Okay.
Okay.
I'm too good for you.
Number which? 26.
Sorry, Emma.
All right, I got a request for 26 from 6.4. So if you are not dealing with this question right now, please just be quietly working on your own. I do not want to have to deal with behavior issues while we are taking questions. So the altitude to the hypotenuse of a right triangle divides the hypotenuse into segments of 4 inches and 12 inches. What are the lengths of the other legs of the triangle? So if I just start drawing this, got the altitude, and that would then give me 4 and 12, right? So I know I need to solve one of these sides that is shared. I'm trying to figure out how I can ask these questions. So I need to pick one side to solve, and then that's going to start like chain reaction to solving all the other sides. I can use this as short leg, or I can combine it to use as part of the hypotenuse. So I can know a short leg here, a medium leg here, or a long leg, whatever you want to call it. Or I can know hypotenuse. So I've got short leg, or long leg, or hypotenuse that I know. So I need to set up some relationship between two of the triangles to make that ratio. Can you think of what part of the triangle, let's just call these, I guess, A, B, and C. What could I use shared? Do you have any idea of where we can head? Do you know where you're going? When? B. Because if I know my 4 and my 12, those are my only values that I can use. And to use them, they have to be diagonal to each other. So if I have this as short leg, and I compare it to long leg, then this 12 has to be long leg. What's the short leg? Questions or answers? On tonight's homework?
How does dilation work with negative? Is it the same? Would it be like?
It's a scale down.
Well, no. But if it says dilation factor of 3 to a negative number, what does that mean against?
Negative number times 3.
Yeah,
Oh, okay.
you just still multiply by 3.
I would've-
Because that point is going to stay in that quadrant, just go further out that quadrant.
Alright, because I thought it meant dilation of 3. I thought it meant it gets bigger, but if it's negative, I thought that would mean it gets
It's still going to get bigger. That negative number is location.
Oh.
That point could be called purple, and it wouldn't it being at -3 and -2, it doesn't matter. Those values, those aren't really negative. It's just a location.
So like,
Okay?
like real world, you couldn't have negative numbers, right?
It's just a location.
No, I mean like in real world situations, you wouldn't have negative numbers working with dilation.
but like, so in real world coordinate geometry, we don't use negative numbers because we use like latitude, longitude, all those values, and we've made those scales all positive. And this gets into this argument because we invented numbers. Like, we made all this happen. So that article that we read about like math being used incorrectly and creating crashes, like we did that. So the fact that that's a negative number, like we made that happen. So we then cross multiply here and get that b squared is equal to 48. And b would be radical 48, or I could reduce it out to be 2. No, it's... Oh, is there a bigger perfect square in there?
It'd be 4 radical 3, right?
Yeah. So then, does that like help you, or do you want to keep going?
No, that helps.
Okay. Because then from there we just set up other means extremes. Other questions?
Okay, another question.
Sweet. This one or different homework?
Different number.
6.5. Which form?
Okay.
Which one?
Could you do 19?
So we have options here, and sometimes options make things difficult. So I can either compare segment to segment, and of course I can go either way with that, which would make me compare segment to segment. Or I can compare short to short, and then long to long, and those could go either direction. So when I set this up, I just really have to make a choice to begin with. And there's really not right or wrong. So if I choose, let's compare my short segment to long segment, then I'll have to compare short to long. So if I have chosen that, then x minus 5, x minus 2, and x minus 1 over 2x plus 1. Oh yeah, this was that question that you asked me about and I asked you to bring up in class. Or maybe it wasn't you, but somebody asked me about this problem. The issue here is when we go to cross multiply. Because I have a binomial times a binomial. And this, I don't know how deep you guys have gone in these processes. This is where FOIL comes in. So FOIL is this process that has nothing to do with aluminum. It's first, outside, inside, last. So, to do that, it's essentially a fancy way to distribute your multiplication. Because if I'm multiplying these binomials, I took my top left, my bottom right, x needs to multiply by the 2x, and it needs to multiply by the 1. The negative 5 needs to multiply by the 2x, and it needs to multiply by the 1. So instead, we do FOIL, which just kind of makes the process easier. Multiply your firsts. I get 2x squared. Multiply your outsides. I get a positive 1x. Multiply your insides. I get a negative 10x. And multiply your lasts. I get a negative 5. I then combine my like terms. I get 2x squared minus 9x minus 5 as my one cross product.
Is that just like the answer? Do you want us to simplify? Wait, no, you can't simplify anything. But like, did I just like the answer?
So this is a working expression. I say working because we're not done. It's still working. That's one of my cross products. To solve for x, I got to do my other cross products, then set them equal, and then solve out the equation. So I'm going to walk all the way through this. So my other cross products come from foiling these guys. So if I do my firsts, I get x squared. If I do my outsides, I get negative x. If I do my insides, I get negative 2x. And if I do my lasts, I get a positive 2. So now I get x squared minus 3x plus 2. So these are my two cross products. I now have to set them equal. So we had x squared
minus 3x plus 2 equals our 2x squared minus 9x minus 5.
Now, there's this fancy schmancy formula called the quadratic equation that if we got this into quadratic form, which what does quadratic mean? Do you know? Well, okay, that's what quad means, 4, but what does quadratic mean?
I took this wisdom that my dad wanted me to do, and it was like it taught me
So, to use the quadratic formula, you would have to set this equal to 0. So you have to combine all your like terms. We're not going to do that. We're not going to apply the quadratic formula because we don't know it yet. So let's see if we can reason through this without it.
If I combine like terms, if I subtract x squared on both sides, that's going to give my right side, let's go green, I guess. My right side will be x squared. If I add 3x on both sides, this will become minus 6x. And if I subtract the 2, I get negative 7.
But that would all be equal to 0. So if I add 7, I have that sum value squared Minus 6x.
Wait. Wouldn't that be minus 3? Is it 2 minus 5?
But I'd be at like, so if we never brought the 7 over here, if instead I add 5 here and add 5, because this is a minus 5. So to get rid of it, I have to add 5. 2 plus 5 will give me 7. Where can we go from here? That's the tough part.
Trial and error?
Trial and error. 1. No. 2. No.
I started with 7 because it was the one on the other side, and it worked. Alvin's just so smart. No, I'm lucky.
You can call it that.
He tries hard. It's not about intelligence, it's about effort. So, trial and error can work here. Is there anything else we could do? If we don't know the quadratic, kind of stuck. If this... Now, what you're actually doing, because there would actually be 2 answers here technically. What? Just to intro this, what this is actually doing is that equation would represent a parabola which has 2 points of intersection, or if it shifts up, it might only have 1 point of intersection, or it might have 0. So what we're doing is solving for the intersections. But I think that was kind of an extension problem, kind of pushing you to do a little bit more work. But as Calvin said, he found 7 to work. Yeah, but negative can't exist there because the lengths of those can't be negative. So essentially what you found is this point would be at -1 and this point would be at 7. So my parabola would be shifted over from its original start point. I agree.
Mr. Hudson, so for 2021, I got it till the last.
Hey guys, I can't hear. You got it.
2021, I got to the last part, so I need to try to find x. I just do trial and error.
On those, you should be able to actually solve it. It shouldn't need trial and error. Let me check this. Yeah, I guess you're already doing it with a square. I don't know what their plan was, because without knowing the quadratic.
Yeah, I guess I might just trial and error. I'm surprised that was on the phone chat. It really, and nobody brought that up to me previously. Like, I didn't think about these coming out in these quadratic formula. I won't put any, like, that hard on this. I don't know why. Because we can solve these. We have the ability. Alright, since we're talking about it, I might as well show it. The quadratic.
Oh, I can recite it.
Okay, you go ahead.
He's saying one, two,
C is opposite B plus or minus the square root of B squared minus 4AC all over 2A.
That's a formula?
Yes.
Oh my god.
What the heck is that?
So, this comes out of.
That's a brain aneurysm.
So this comes out of solving for x when you have x squared and in its one like single power form. So when you have a trinomial with one of your x's of the second power, one of the first power, and then a constant value, if you derive down to isolate the x, that's where the quadratic formula comes from. So it's not just some thing that like some guy made up. It literally is, if in any algebraic form, A, B, and C as whatever you want them to be, that will always work to find the points of intersection where y is 0 and x has a value.
Question. Yeah,
We're not there yet. Quadratics is like chapter 12.
So will you expect us to write this all out?
I will expect you to understand how to use it.
Alright, but not write it all out.
No, by the time we get done with it, you'll probably have it memorized. So, the formula itself is just this.
Oh, thank God.
This is the proof
Oh,
of
I thought
how
that
it
was
gets
the
there.
formula.
No, because we start with the trinomial like what we had up here. 2x squared minus 9x minus 5. That's just a trinomial or a quadratic.
Okay.
So then we derive x through that way, through that method.
Why is that so scary?
Because
He's a
that looks like
baby.
a brain aneurysm.
All you have to, like, all this is solving for x.
Yeah, but
he's just making it. Caleb's just being
I'm
Caleb.
exaggerating, but that does look. Okay, I thought that was all just to solve for x. I thought that
It is.
entire. Well, no, but I thought that was the simplified version of the equation. I wasn't aware that the very
Dude,
bottom.
do you not
part-
see like the 8 equal signs?
Well, don't judge me, Carmen.
But all of that to say, we don't need this yet. We just brought it up, so I can't bring things up and not explain to you at least a little bit about what we're going to do with it.
But if you just practice it.
Well, if you practice anything, it won't be.
Thank you. That's what I'm saying.
But that doesn't make it any less tough when you don't practice.
All right, you guys have a little under 5 minutes left. Any other homework questions?
Is there anything I can hear Caleb whine about more before I leave?
Probably.
Yeah.
Bring up anything that creates a lot of work.
Yeah.